Today we discuss about Kreb cycle. That's what is Kreb cycle, how much step involved in Kreb cycle, how many ATP produce in Kreb cycle, how many FADH2 produce in Kreb cycle, how many NADH2 produce in Kreb cycle, and which type of enzyme involved in Kreb cycle. So these all we discuss in today's lecture. And first we discuss about the term Kreb cycle. It is called Kreb cycle because for the first time Hans Kreb sentence was the name of sentence Hans Kreb. Hans Kreb discovered Kreb cycle in 1930. Due to their discovery, it is called Kreb cycle. Kreb cycle, also called citric acid cycle, because their first molecule made is citric acid. It's also called tricarboxylic acid cycle, TCA. So we discuss now the definition of Kreb cycle. That what is Kreb cycle? Kreb cycle is a chemical reaction. Kreb cycle is a series of reactions in which a series of chemical reaction in which the pyruvate from glycolysis in which the pyruvate from glycolysis is oxidized to carbon dioxide under aerobic condition is called Kreb cycle. Kreb cycle is a series of chemical reaction in which a pyruvate from glycolysis is oxidized to carbon dioxide under aerobic condition is called Kreb cycle. This was the definition of Kreb cycle. Now we discuss the steps and enzyme involved in the Kreb cycle. So we draw the structure, the diagram in the form of cycle of Kreb cycle. So the Kreb cycle occur in mitochondria. There are three things. First is glycolysis, which occur in cytoplasm, and the next two, the Kreb cycle and electron transport change, occur in mitochondria. So here the Kreb cycle process occur inside the mitochondria. In mitochondria, a 4-carbon compound present called oxaloacetate. Oxaloacetate is 4-carbon compound which present inside the mitochondria. It combines with the acetyl coenzyme A. Acetyl coenzyme A. Acetyl coenzyme A is 2-carbon molecule which came from link reaction. The oxaloacetate and acetyl coenzyme A both combine through a enzyme. Enzyme name is citrate synthase. Enzyme citrate synthase. Oxaloacetate combined with acetyl coenzyme A through enzyme citrate synthase and make 6-carbon compound called citrate. Citrate or citric acid. It is 6-carbon compound. Here, in next step, the citric acid convert into cis-aconitate. Cis-aconitate also 6-carbon compound. In this step, enzyme involved aconitase. Aconitase is the enzyme which converts citric acid into cis-aconitate. And next step, the 6-aconitate convert into isocitrate. Convert into isocitrate. Convert into isocitrate. Isocitrate also 6-carbon compound. Isocitrate is also 6-carbon compound. In this step, the enzyme which name is aconitase. And next step, the isocitrate convert into alpha ketoglutarate. Alpha ketoglutarate. It is 5-carbon compound. Here 1 carbon dioxide molecule is released and also H2 release. H2 attached to NAD and convert NAD into NADH2. In this step, also enzyme involved which name is isocitrate dehydrogenase. Enzyme name is isocitrate dehydrogenase. Then alpha ketoglutarate, which is 5-carbon compound, is convert into succinyl coenzyme A. Succinyl coenzyme A. It is 4-carbon compound. Here another CO2 molecule is released and coenzyme A is enter. And here also 2 H atom release and attached to NAD. Here NAD convert into NADH2. In this step, also enzyme use which name is alpha ketoglutarate dehydrogenase. Enzyme name is alpha ketoglutarate dehydrogenase. Then the succinyl coenzyme A is converted into succinate. Succinate is also 4-carbon compound. In this step, enzyme involved which name is succinyl coenzyme A synthase. Succinyl coenzyme A synthase. When succinyl coenzyme A convert into succinate, in this step, one ATP molecule produce. And then the succinate convert into fumarate. Fumarate also 4-carbon compound. When succinate convert into fumarate, in this step H2 release. Which convert FAD into FADH2. In this step also enzyme use which name is succinate dehydrogenase. Enzyme name is succinate dehydrogenase. And then fumarate convert into malate. Malate is also 4-carbon compound. In this step, enzyme use which name is fumarase. Enzyme name is fumarase. And then malate convert into oxaloacetate. In this step, enzyme use malate dehydrogenase. Malate dehydrogenase. In this step also H2 release from malate which convert NAD into NADH2. Short. Once again, oxaloacetate is 4-carbon compound which present in mitochondria. Combined with acetyl coenzyme A, acetyl coenzyme A is 2-carbon compound which came from link reaction. When these both combine through enzyme citrate synthase, it makes citric acid. Citric acid is 6-carbon compound. Then citric acid is converted into cis-aconitase through aconitase enzyme. Then cis-aconitate convert into then isocitrate. Cis-aconitate convert into isocitrate through enzyme which name is aconitase. Then isocitrate convert into alpha-ketoglutarate. Alpha-ketoglutarate is 5-carbon compound. Here, when isocitrate convert into alpha-ketoglutarate, here one molecule of carbon dioxide release from the cycle and NAD convert into NADH2. Then alpha-ketoglutarate convert into succinyl coenzyme A. Here another carbon dioxide molecule release and H2 attached to NAD make NADH2. And thus then succinyl coenzyme A convert into succinate. Here one ATP generate. Then succinate convert into fumarate. Here also H2 molecule release from succinate and convert FAD into FADH2. Then fumarate convert into malate and then malate convert into oxaloacetate. In this step another H2 molecule release which attach to NAD and convert NAD into NADH2. So net in one Kreb cycle direct ATP produce 1, FADH2 produce 1, NADH2 produce 3, 1, 2, 3. In one Kreb cycle, 1 ATP produced directly, 1 FADH2 produce and 3 NADH2 produce. The FADH2 and NADH2 go to electron transport change where it convert into ATP. This was all about the Kreb cycle.